This lesson is about the different kinds of things that can go into a class. We've looked at the different kinds of data items that you can put in a class. You can put a data item just about anywhere you'd like to have one, inside or outside of any of the methods. The general rules are simple enough. A data item can be accessed by code within its enclosing braces and from within the enclosing brace pairs nested inside those outer braces. However, you should always be aware that if you declare a data item with the same name as a data item available from an outer scope, your more local name will be recognized instead of the one from outside. This is called overriding. The more local definition will always override the more global definition. Here, let me show you. The program named Moose overrides a variable a couple of times. Here you see the int variable named Moose declared outside of any method, which means it can be addressed from inside any method, including the constructor. In the constructor, the value of Moose is displayed, then a new declaration of an int is made, but this one has a different value, and then the value of Moose is displayed again, but this time it will be the inner one instead of the outer one, like this. This is also true of inheritance. If you have a data item from a superclass and you define that item in a subclass, the one in the subclass overrides the one in the superclass. The moral of the story is that you need to be careful what you name things. You could accidentally override something, and that can be a tough bug to find. I'll be showing you some more about access to data items in a couple of lessons. A class also contains methods. There is some overriding possible here too, and there is also overloading. But first you need to know how methods are named. The name of a method includes a complete list of its argument types in order. For example, if a method named Fred has one int argument and one double argument, its full name is Fred int double. You can have lots of other methods named Fred in your class as long as they all have a different list of argument types. This class has several overloaded methods named setSize. These methods all do exactly the same thing. They set the internal area of the figure, but they do it by accepting a different set of argument types. It's easy to tell the three methods apart because they all have different names. The first one is called setSize double. The second one is called setSize double double. And the third one is setSize Java AWT dimension. There can be no doubt about which one is being called. Notice the method at the very bottom, the one named initialize. It's calling setSize with an int value, but none of the ones defined have an int argument. Remember the thing I talked about earlier, the widening and narrowing of values? As long as no precision is lost, Java will convert the value to another type and call the matching method. In this case, an int is converted to a double and the method's called. The conversion is widening because an int is only 32 bits in size, and a double contains 52 bits of digit information. You can go the other way, the value can be narrowed, but that requires casting to force it to fit. And one method can override another. But that only happens during inheritance. If the superclass contains a method and you write a method with the same name and the same set of arguments, your method will override the one in the superclass. This is the main way in which a subclass makes changes to the definition of a superclass. A constructor is like a method, but it's called only once, and that's when an object is being constructed from a class definition. You can always spot a constructor because it has no return value defined, and it has the same name as the class. Just like the methods, you can have several constructors as long as they all have different types of arguments. You can have other classes defined inside a class. These are called inner classes or nested classes. The inner class definition can extend another class and thus inherit some things that it cannot create on its own. For example, an inner class can't declare a static data item unless that item is a compile time constant. For the most part, inner classes can only be used inside their enclosing class. You'll find out more about all of this now in the next couple of lessons.